Hey everyone, welcome to my channel. In this video series, I'm explaining top LeetCode questions. So if you are preparing for the interview, these videos are definitely going to help you out. In this video, I'm explaining some more most frequently asked array questions. So let's dig in and conquer the LeetCode questions.
So the next question is maximum sum subarray. So we have given an array with the negative and positive numbers, and we need to find the length of the largest subarray where we have the maximum sum. So in this question, so this is very famous question which is solved with the Kadane's algorithm. So in this algorithm, we keep track of two variables. One is your local sum, okay, and another one is the global sum. So our global sum will be the containing the sum of the largest subarray, and the local sum will be keeping count of the local sum. Means while traversing the array, we will be keeping the count of the elements in the local sum. So it will make more sense once we take the example. Okay, so let's take an example of 5, 4, -1, 7 and 8. So in this example, so the local sum and global sum by default will store the first element. So that will be in just, this is the basic case where you have just one element, so that will be your global sum and local sum. So you can just return the global sum. So starting with the second element, so the 4. So how do you calculate the local sum? So local sum is equal to max of local sum plus current element or current element itself, or and the global sum is equal to max of global sum or local sum. So these are the formulas. So when you come to the 4, so at the time local sum is already 5. So in this case 5 plus 4 comma 4, so max of those two is 9. You will update the local sum, and then here global sum is 5, local sum is 9. So in this case you will get 9 and you will update it. So at any point of time, when the local sum is greater than the global sum, we will update the global sum. So 4 is processed, come to the -1. So in this case now the local sum is 9. So 9 minus 1 comma -1. So in this case maximum is, so that will result 8. So we'll update 8. So 8 minus 1 maximum is 8. So we'll update local sum with 8. So 8 is not greater than 9. So we'll not update the global sum. So 1 is processed. We'll take example of 7. So 7. So in this case so let's take an example of 7. So in case of 7, so local sum is 8. 8 plus 7 comma 7. So that will result in 15. 15 is greater than a global sum. So we'll update the global sum also with the local sum. So 7 is processed. We'll go with 8. So same again. 15 plus 8 comma 8. 15 and 8 is 23. So you will update local sum to 23. Local sum is greater than global sum, so you will update global sum also. So now the whole array is processed and you can return the global sum. So 23 is your answer here. So that's the Kadane algorithm. So you will keep track of the local sum and the global sum, and then you can return the answer. So thank you. So this question is on grouping the anagrams. So we have given an array of strings and we want to group them together if they are an anagram of each other. So for example, here we have given eat and tea. So if you sort them out, so what you will get is 80, 80. On the sorted format, they end up with the same string, and if so, it means they are anagram of each other. And if they are anagram of each other, then we need to group them together. So the answer will contain AET, EET, and T, right? So how do you do that? So the one way is you traverse this array, okay, and let's say if we are processing it, you will sort it, okay, and then you will store it in a hash map. So the hash map key can be the sorted format, and then you can see if you have encountered any string before. If not, you can just keep your answer and start moving to the second element. So your second element is T. Again, T, you will sort it, it will end up with the 80. 8 is already there, so you will append your answer again. Okay, then again 10, 10 you will sort it, will again A and T, then A and T will be stored as, will be storing your answer. Same goes with the ATE. So ATE will sort it, AET and ATE. So like this you can process the whole array and you can get your answer, and the answer will be stored in this map, so you can process this and return in the proper format. So if you see here, along with the processing the array, which will be order of n, we are also sorting each word, which will be, let's say if the length of the word, average length of the word is k, you will be processing log k also again, right? So again that will be log k into n, so n log k will be your complexity. So the most of time interviewer are going to ask you, is there a way you can process this efficiently? Okay, so what so the next optimization you can do, so if you see, you wanted to end up, you wanted to find out if two words are anagram of each other, right? And that's why you sorted the word, right? So is there a way without sorting you can end up with the same anagram? So the answer is yes. So what we can do is, you can keep a constant array of 26 length, okay, so and you can store each word frequency, let's say EAT, right? So 0 1 1 2 3 4. So you will keep the frequency of character here. So A is coming once, so A will be 1, then B is 0, then C is 0, D is 0, and E is 1, following up with the T is 1, and following up with the Z is 0. So you got the one array of the frequency, then you can create a string out of it. So you can take a one delimiter here, so 1 hash 0 hash 0 hash 0 hash and 1, and following up with the 1 hash 0 hash and following up with the 0. So you will end up with the string, and you can use this string. So even if you create the same frequency map, you will end up with the same frequency map, and you will end up with the same string, and from this string you can identify in this map. So you can use this as a key in the map to identify whether two strings are an anagram of each other or not. If they are, you can group them together and then process the whole array. You will, at the end of the processing, you will get your answer in the map, and you can return that into your answer. So the complexity here is, since this is a constant time array, so it's only 26 element, so it will be a constant processing. So at the end you will be processing in of n time only. So that will be the complexity here. So the next question here is that we need to search in a rotated sorted array, and since this is rotated, we need to find the index of the target element, and it has to be in the log n runtime complexity. So as we already learned from my previous videos, since the array is sorted and we need to search an element, we need to use the binary search. Okay, but the main condition for a binary search, that array has to be sorted, but in this case, since it has been rotated, okay, so in that case array will not be sorted anymore, right? So if you see, this is not a sorted array anymore. So how do we run the binary search in this array is the question, right? So if we take a closer look on this array, so it's still sorted, but it has been divided into two sorted arrays separated by a number right? So if we can find out where the separation is happening between these two sorted arrays, then basically we can run binary search. So basically in that case we can find out whether the target element is present on this particular array or this particular array, and since both of them are sorted, we can run individually binary search, right? So the question is reduced to how to find this particular element where the separation is happening, right? So how do we find this? So there's a simple property to that. So there's a property in, if you see, let's say this is a sorted array, right? So the rightmost part of the sorted array will be the greatest element in the whole array, right? So for example, let's take in this case, so this will be mid, right? So if you see, so how do you calculate the mid? 0 plus 0 plus 6 divided by 2 will be 3. So third element will be your mid. So in this case 7 is the mid. So if you compare 7 with the 2, so 2 is the rightmost part. So how the, so this left is pointing here, right is pointing here, and this will be your mid. Okay, so if you compare mid with the right, so you will get 7 and 2, and if you compare 2, 7 is greater than 2, so the right is not the greatest element anymore. So if you so what we can do in this case, we can just move left to the right. Okay, so we'll make left equals to mid plus 1. So now mid is, so left is pointing to here, left is pointing to 4. So now 0 1 2 4 5 6, and the left is here, right is here, so the now mid will be here, right? So let's do it again. Okay, so one compare, so if you compare mid with the right, so in this case it's, this property is holding, right? So mid is less than right, so which is correct, it should have been like this. So what do you do that now? What you will do is you will move right to the mid. So let's calculate the mid again. So 4 plus 5 minus 4 divided by 2 will be 4. So the mid will be here. So compare 0 and 1. So since it's again holding the same property, 0 is less than 1. So right will be pointing here. Since left and right are pointing to the same index, you found the element. So that's how the algorithm will work. So you will keep pointing right, so left to the right if this property does not hold true, but if it does hold true, you will move right pointer to the mid. So that's how you can find the 0th element. Now once you found the 0th, the separated index, now you will know the target element. So in this case the target is 0, right? So 0 right now is pointing to the right side part of the array, and so you will run a binary search on the right side of the part of the array. So there you have it. So the runtime complexity will be finding, so finding the separated index will be log n, and then finding again the element index will be another log n, right? So the worst case will be